Section 10.4 is geometric probability. Our goal is to use segment and area models to find the probabilities of events. On page 765, we have, in the Solve It, you found a probability involving a coin. In this lesson, you will find probabilities based on lengths and areas. The probability of an event, written P of event, is the likelihood that the event will occur. When the possible outcomes are equally likely, the theoretical probability of an event is the ratio of the number of favorable outcomes to the number of possible outcomes. So we have the probability of the event is the number of favorable outcomes divided by the number of possible outcomes. Recall that a probability can be expressed as a fraction, a decimal, or a percent. You can use geometric models to solve certain types of probability problems. In geometric probability, points on a segment or any region of a plane represent outcomes. The geometric probability of an event is a ratio that involves geometric measures such as length or area. On page 765, we also have point S on segment AD is chosen at random. The probability that S is on segment BC is the ratio of the length of segment BC to the length of segment AD. So we have the probability of S on segment BC is the length of BC divided by the length of AD. Example 1 says point K on line segment ST is chosen at random. What is the probability that K lies on line segment QR? Up here, I just have the information from the previous slide. Notice that ST is a segment from 2 to 14 and QR is a segment from 5 to 8. The probability that K lies on line segment QR would be the length of segment QR divided by the length of segment ST. Segment QR starts at 5 and ends at 8. We can count on the number line to see that segment QR has a length of 3 and ST goes from 2 to 14, so we can count to get 12. We can also use the values on the number line to get 8 minus 5 equals 3 and 14 minus 2 equals 12. Simplifying 3 over 12, we get 1 over 4. Therefore, the probability that K lies on line segment QR is 1/4 or 25%. The work for this problem is written out on the next slide. And now I would like you to try number 1. A point on line segment AK is chosen at random. Find the probability that the point lies on the given segment. For number 1, we're looking at line segment DJ.